Okay, so now what we're going to do is we're going to algebraically find a delta value given a function, given a limit, given some number that we're investigating c, and some tolerance on y that we're going to call epsilon. So there's basically a two-step process here. First thing we have to do is solve the inequality that they reference over here. All right, we solve that inequality, and once we've solved that inequality, we can find the delta, and we're going to do that. We can sketch it on a number line really quickly, and I think we'll see how this works. So let's go ahead and take a look. First thing I'm going to do is I'm going to write out that inequality that we get from the definition of the limit. All right, f of x, absolute value of f of x minus the limit L is less than the y tolerance epsilon. All right, so let's see, what is f of x? In our problem here, it's 10x minus 1 minus the limit happens to be 29, and it has to be less than epsilon, which is 0.01. When I combine my like terms here, I'm going to have 10x minus 30 less than 0.01. All right, and I'm going to transform this absolute value inequality into a compound inequality that looks something like this. Okay. All right, now I'm going to add 30 to both sides. Add 30. All right, and I get something like $29.99. Feel like I'm at the store now shopping for something. Less than 30.01, and we're going to divide by 10. Everything by 10 to solve the inequality. Okay, we're going to get 2.999 less than x less than 3.001. So this is our interval from A to B. Okay, so what we're going to do, we can draw out our number line. Our c value that we're investigating around is the number 3. Okay, now notice the 3 we didn't utilize anywhere, but notice how conveniently it works, because the inequality for the limit there, all right, has to tell us, you know, around what x values we're going to be looking at in order to find a limit of 29. Okay, so we have to be around that ballpark. So I'm going to write out 2.999 and 3.001, and this area right here, this interval, if you will, tells us our delta value. Now, coincidentally, it is symmetric. So both of the deltas that we obtain are exactly the same. And normally you'd take the smaller one because that's the greatest spread you're able to tolerate. Okay, but in this case, it's symmetric. So both of the deltas on either side of 3 are identical. So that is the tolerance on the x value. We have to be between 0.001 units from 3 in order to have a limit of 29. Otherwise, the limit would be something else. If you're looking at something greater than or less than 2.999 or 3.001. So just a little note here, an example on how you can algebraically find delta. So as always, if this video was helpful, be sure to like and subscribe.